This is the 2014 differentiation paper. I'm just going to go through every question and write in some answers as we go. Okay, question 1. This is a very simple achieved question, so I'm going to put a little U on here. This is the chain rule, so dy by dx will be equal to -5 sine 3x. This is the derivative of the outside function, which is cos, times the derivative of the inner function, which is just going to be 3, giving us -15 sine 3x. Okay, next slide. Find the gradient of the normal to the function y equals 3x squared minus 5x all squared at the point 1, 4. So we're going to use the chain rule to differentiate this. We'll work out the gradient of the tangent, and then we'll get the gradient of the normal. We're going to do that at the point 1, 4. This is also an achieved question. Okay, so first differentiating, we're going to get dy by dx is equal to 2 into 3x squared minus 5x. Next we have to take the derivative of the inside function, which will be 6x take away 5. We need to find the gradient at this point, 1, 4, so we evaluate the derivative when x equals 1. So at x equals 1, dy by dx is equal to 2 times 3 minus 5 times 6 minus 5, which is going to give me 2 times -2 times 1, -4. So the normal gradient is going to be 1/4. Okay, remember that this number and this number have to multiply together to give you -1. This derivative is the gradient of the tangent. This one's the gradient of the normal. Question 1c. This is a little parametric differentiation question. We're given x in terms of t and y in terms of t. So to find dy by dx, we first find dy by dt and dy, whoops, let me just fix that up, dx by dt. So dy by dt will be -2 sine 2t, and dx by dt will be 2 cosine of t. So dy by dx, it's just an application of the chain rule, is dy by dt divided by dx by dt. Whoops, I've made another mistake. Just let me get rid of that. That should be a t, not an x. We've already got those two derivatives, so it's simply -2 sine 2t divided by 2 cosine of t. Now, we can simplify this because we know that sine of 2t is 2 sine t cos t. So that's -2 sine t cosine t times 2. Whoops, we forgot the times 2. There we go, divided by 2 cosine t. These simplify, this simplifies with that, and we're left with -2 sine t. Okay, I'm just going to try something with explain everything at this point to see if I can do separate slides. So I'm going to stop here and pick up again recording in another minute or two. Okay, just reading through the question, we're being asked to find the x value at which the tangent to this function is parallel to the x-axis. So just thinking about what that means, I've got my x-axis here. I'm looking for the place where dy by dx equals 0. It's just a fancy way to ask for that. So the first thing we want to do is differentiate. We'll start by flipping that function out of being a fraction. So we're going to do this. Y equals 4e to the power of negative 2x minus 2 plus 8x. Okay, we might as well just leave it like that. Or if it makes you feel better, we could do this. 4e to the negative 2x plus 2 plus 8x. Okay, so we're going to start by differentiating that. We get dy by dx is equal to, okay, chain rule, it will be 4e to the negative 2x plus 2, because remember the derivative of e to the x is just e to the x. Now we need to times by the derivative of negative 2x plus 2, so it's just that, plus 8, which is negative 8e to the negative 2x plus 2 plus 8. So we need to find when that equals 0. So 0 equals plus 8. 8 equals 8e to the negative 2x plus 2, e to the negative 2x plus 2 equals 1. Now I just have to work out how to add in a new slide, so I'm going to try that now. Hopefully this will work. Okay, I'm still trying to get the hang of this, so let's just see what I've got to solve. I've got to solve e to the negative 2x. Yes, it worked. Okay, so just, right, let's try this. E to the negative 2x plus 2 equals 1. Well, e to the power of 0 will be 1. Right. So we know that we need negative 2x plus 2 is equal to 0. X equals 1. That's it. We're done. So that is a merit question. If you got the derivative correct, then you got an achieved tick for that one. Okay, I'm having a bit of trouble figuring out how to do harder questions without getting into a mess with blank slides. So we'll give this a go. Hopefully it will work. First thing to do when you get a harder question like this is to try and put it into a simpler diagram and just look what we're being asked to find. So what is the maximum volume of a cone if the slant length of the cone is 20 centimetres? First thing to notice is that I've got a little right angle triangle, so I'm going to use that. Here's my radius, here's my height, and we know that that length is 20. So I'm going to use Pythagoras to set up a relationship between h and r. So I'm going to get h squared plus r squared equals 400. Then I'm going to look at the formula for the volume of a cone. Now, the volume of a cone is V equals 1/3 pi r squared h. If I'm being asked to find the maximum volume, I'm going to want to find either dV by dr or dV by dh equals 0. Now, in this case, what I'm going to do is I'm going to say h squared equals 400 minus r squared, and then h is just the square root of that. I could do it the other way around and get an expression for r squared. Doesn't really matter. Although looking at it, that might be a simpler way to go. So we might come back to that and try doing it the other way around if my explain everything's working well. So now what I want to do is to get a new slide to come up and show you how to substitute this into here, because that's the next step. Okay, so we've got V is equal to 1/3 pi r squared h, and we're going to substitute that, and we get V is equal to 1/3 pi r squared root 400 minus r squared. So we want to find dV by dr equals 0. Before I do that though, I'm going to simplify my volume expression like this. So dV by dr I'll get using the product rule. So here's my first bit, here's my second bit. If you like thinking about u and v, this is u and this is v. So dv by dr is equal to 1/3 pi r squared times 1/2 of 400 minus r squared times negative 2r. Right, and then flip it over and do it the other way around, plus 2/3 pi r times 400 minus r squared to the 1/2. Right, now we need to do a little bit of simplifying here. I'm going to get a common denominator going. It's going to be 400 minus r squared, the common factor of 3. So this first term here will leave me with, that's that done. Let's have a look. Negative r, oh, why is my pen going funny? Negative r times pi r squared. Right, because the negative 2 and the 2 there simplify out, pi r cubed, so that's that bit, plus 2 pi r times 400 minus r squared. Okay, so now I get what's left. Let's see. I've got 3 root 400 minus r squared on the bottom line. Top line is going to be, something's wrong there. What have I got there? That should just be a 1. No. Yes, that should just be a 1. So that should be pi r cubed, negative pi r cubed, plus 800 pi r minus 2 pi r cubed. Now that doesn't look very nice, but that is going to simplify quite easily. So we now need to make that equal to 0. Try getting another slide to come up. So we get negative 3 pi r cubed just checking that, negative 3 pi r cubed. I need to go back to the last slide, this is really annoying. Plus 800 pi r divided by that bottom line, which is 3 root 400 minus r squared. So this is, reminding you, this is dv by dr. Now, that looks horrible. We need to make it equal to 0. But if you look at that bottom line, that can never be 0. So the only way the whole thing can be 0 is if I have this. 3 pi r cubed equals 800 pi r. Now the pi's go, and I can divide through by a common factor of r, and I get 3r squared is equal to 800. So now r squared is equal to 800 over 3. Right, and now getting my calculator out, I get r is equal to 16.3, and that is centimetres. Because if you think back to the original cone, we had that length there being 20 centimetres. Okay, so the radius must be 16.3 centimetres in order to maximise the volume of that cone.